Uh, okay, hello viewers, welcome back uh, to our video number 5, in which we are going to start with the main work. So I think we are now going to we have finished with the section motivation. I think the next section is the main work, so I will create a new section which I will call main work. So under this section we are going to have a frame. So we begin a frame in which we are going to put the description of the method. Correct? We are going to put a description of the method under this frame. I'm coming, please. Okay, so we need a frame title, of course. Here, frame title. The frame title is description of the method. Now in this frame we are going to now describe the method. So from what I have seen here, I'm going to start with in this section we are going to describe the scheme of the convex combination spectral approach for finding the solution of large-scale nonlinear system of equation. So let me type it in this section, or instead of this section, in this slide, since we are just presentation. We are going to present a scheme of the convex combination spectral approach for finding the solution of large-scale system of nonlinear equation. Instead of this one, which is manually, I will just eqref equation 1. Remember eq1, so that is what it will do. So in which the underlying function is assumed to satisfy the Lipschitzian condition. So is assumed to satisfy the Lipschitzian condition, that is, there exists a non-negative constant L such that so I will put the Lipschitzian condition now as an equation. Begin equation and equation. Maybe I don't want to number it, or maybe I can number it so that I can recall it somewhere in my slide. So the Lipschitzian condition is the norm of f of x, norm of f of x minus f of y in norm is less than or equals to LEQ, L, capital L now, then norm of x minus y of of course, what is x and y, we can say for all x, y in Rn. So this one now is a text, but we want it to be in line with the equation, so we can use quad and then put it in a text for all. Then we put tilde there, we close the bracket, and then because what we are going to write now is in mass mode, so we can just leave it like that, x comma y in backslash backslash math bb rn, so r then power n, okay, so that is it. Then we continue with the description of the method, maybe as an itemized description, because we first of all we have to define the scheme, and then we give the positive spectral coefficient. Yeah, so we can just say maybe begin itemize, and itemize, then item. We can start with saying that the scheme is recursively given us, or in other words you can say iteratively, all the same, given us. Then I think we have it in one of the equation I write, that is equation 2. I don't know whether I have leveled it. Let me go back, leveling equation 2. If I have leveled it, oh, I didn't level it, so I have to level it, backslash level EQ, because I want to refer to it now in my here. So the scheme is possibly giving us backslash since it is an equation, we have EQ ref EQ2. So that is it. So that is the first item. Then second item will be now the what we have in scheme 2. So you see we have lambda and we have alpha. So lambda k we say is the step length, then the alpha is where the spectral coefficient, that is the spectral coefficient. Then let's first of all start with it. The spectral coefficient alpha k is a convex combination. You can just say where alpha k is a convex combination, or where the spectral coefficient alpha k is a convex combination of two spectral coefficients, so defined by that. Let us take it. So the spectral coefficient alpha k in mass mode, alpha k is a convex combination of two positive spectral coefficients. The two positive spectral coefficient is alpha. I think we have the first one is alpha bar, and the other one is alpha tilde. So maybe we can just start with bar alpha, okay. Then we put text. I don't want to go out of the max mode, and I'll put just text. I'll put tilde there, then and I'll put another tilde to create a space. So then alpha tilde, that is tilde alpha, defined by now I'm going to put an equation. the equation is alpha k is equals to that base combination, and then we define the so backslash begin equation. This equation I don't want it to be numbered. Maybe I would just say unnumbered equation, and then we said alpha k is equals to okay, well, I need it to be numbered. Let me remove the star. Alpha k is equals to eta k alpha k bar. Okay, now I have to put backslash eta k. Now copy alpha k bar there, I'll paste it here, then plus 1 minus backslash, since they say it's it's a base combination, so we have base combination eta, then 1 minus eta in the other term. The other term is tilde alpha, so tilde alpha k. So again, but we have to define what is this alpha tilde and alpha bar. Yes, so we have to say where then we start with the alpha bar, and then alpha k tilde. So where all of them in as an equation, so begin equation in just one equation, numbered equation, begin equation, then we start with alpha bar is equal to, I think the definition is norm of sk to the power 4 fraction is frac. Maybe let me just copy the previous one I have, then I will just modify it. I think I have, yeah, I have somewhere where I have written it, so I will just copy, but it's not the same. I will just modify it. Alright, alpha k is equals to, this one is to the power 4, and this one is w now, not y, then that is alpha k. So apart from alpha k, we have alpha k tilde also, so that one we have comma, maybe tilde backslash tilde alpha is equal to well, this one is not, is a frac of norm of s k minus 1 s k minus 1 cubed. Then the denominator I think is wk minus 1. Is it norm? In norm, yes, norm of wk minus 1. So again, here we also have some unknown, which is wk and eta k. So we have to know what is eta k and wk. So maybe in this equation we can put the eta k there, or we can just put comma, and then say we exit from the equation environment. We say where, or let's say with backslash eta k in 0, 1. So eta k is a positive number between 0 and 1, and wk must be in terms of equation. Yeah, it must be equation numbered. So backslash begin equation and equation, and then we say wk minus 1 will be equals to, so the inner product of y and s, then times y. Okay. So we don't need to even number wk's. Okay, I think I can just put star there. So it's the inner product of y of yk minus 1 sk. No, here is sk, I put x. Sorry, let me correct it. It's s, not x. Even in the initial one, equation 2 is a typo, definitely. I mean, it's s, not x, in that inner product. So I have the inner product of this, then times yk minus 1 then plus r, then num of sk minus 1 sk minus 1 squared, and then times sk. And then sk minus 1. So here also I need the r backslash quad maybe, and I put r bigger than 0. R is just a real number bigger than 0. So this is the slide. I don't know whether we made a mistake. Let me just compile it and see. It's a slide that is describing our new spectral coefficient, the one that we are going to use. Okay. Okay, so you see there are some mistakes in the typo. Where we put alpha, we didn't put the backslash alpha maybe. Yeah, so we have to put backslash to give us alpha. Backslash, where is another alpha? This is another alpha. Backslash backslash, then let me run it again. So you see I put so many things in the slide, and it happens even the last wk I type, it doesn't come out. Maybe I can just remove it in I'll leave it to be in the form of inline equation. Let it be a line equation, let it be in line with the eta. Let me just copy it like that. so X, and then I'll just make this one to be a text. Okay, and then, well, it happens that we spend about 20 minutes in just one slide, but it's just a demonstration. Of course, we may not be able to spend the time. Okay, this is to our okay, I made a mistake somewhere. I'm supposed to have something to power 2, correct? Look at it there, I put power S, and it's supposed to be power 2, and then S is different. S is just times in the norm of sk. That's last line. And there is also additional, you see I didn't put space between between eta k and wk. Look at it. So it even go out, but I will make sure it's come down, it's come inside the slide. I don't want anything to be outside the slide. So maybe what I will do is I will reduce the length between that equation and itemize b space, maybe minus 0.5 centimeter. So this the space between that Lipschitzian condition and then where we started our scheme. Yeah, so you see I reduced the scheme, I reduced the vertical vertical distance, and my last equation now come out. It is on the slide now, we can see it. So this is how we, okay, there is one alpha that I forget to put backslash on it. Look at it in equation 5. So I put backslash on it and run my or compile my document again. Now I am in the 6th slide, that is, but I think 6th slide is including the what do you call it, the title slide. Let me see. Yeah, so not including the title slide. Now I have made about 5 slides, correct? So in the next video, because we have spent a lot of time here, in the next video I'll try to make it fast. Maybe I'll find the source code for this paper so that I will just copy and paste, so that we can be able to do so many things in some minutes. So thank you very much for watching. We meet in the next video, inshallah.